Welcome everyone. In this video I'm going to talk about the TCD1304 linear CCD again. As you can see, I unwrapped something which I have received from the sponsor of this video, PCBWay, and this thing is nothing else than my own circuit which is designed for the TCD1304 PCB. So I will review this PCB and then I will also build a circuit and hope that it will work as it intended. So what I want to do with this circuit is I want to mount the CCD on this side, and then on the other side I have a few parts which are surface mounted parts, as you can see, and I will at this point hand solder them to the corresponding positions. And the whole thing will go on top of a STM32.401 microcontroller. So it will click on the microcontroller board and it will hopefully stay there as well. And yeah, so I have these boards. As you can see, they are black. And I ordered 5, but I received 6. So thank you very much, PCBWay. I have one extra board, probably for practicing and so on. And you can see that these boards are black. I designed them to be black and this kind of a dark black because, yeah, it looks cool, but also it reflects less light. But you can see that it's a bit still sort of shiny. But they have a matte black color, so if you really want to have a very black color which does not reflect too much light, then you should go for that. But this is perfect for my purpose. And what I did on this front side, I kept the silk for the let's say courtyards for the pin headers and for the TCD1304. And also I printed some nice text. I will take a picture of this so you will see it better, but it's just an indication about the board and its designation and so on. And to make my work a bit more easy, I have the two sides also indicated here. So I know that on the microcontroller, one of the rows for the pins is the 3.3 volt and the other is with VB, or for the battery power, and then the USB connection comes to this part, but this is just to indicate the alignment of the pin. And then on the other side you can see the pads for the surface mounted devices. We have a few components like capacitors, resistors, a operational amplifier, as well as a voltage reference, and hopefully they will suit my design and it will work properly. And as you can see, there are 4 holes at the corners, and yeah, they are just for mounting. So I can mount this whole board together with the PCB on this side, which is the microcontroller, and with the CCD on this side, and it will, yeah, you can mount it on a device or something. On an enclosure, and it makes it easier to use. Or also you can put it in an enclosure and, yeah, put the bolt through these holes through this way. So yeah, as far as I can see, all of these boards look perfect. I can say that the printing is very nice quality on both sides. So all the let's say component abbreviations, R1, R2, and so on, they are very nicely shown. The printing looks good. The tabs for the soldering look perfect and flawless. They follow the tabs very nicely. That's I really like. Also these holes for the components look just perfect. There are no sharp edges. I really like that. There are no sharp edges on the board, so they will not hurt me. I don't know if they polish it or it is just from the very fine cutting tool that they use, but I'm always very satisfied with their boards, especially of the edge quality. In my day-to-day work, I work with sharp metal pieces, and it's always nice to have something with smooth edges. So I really appreciate this. Thank you. And Then obviously the next part which I will review will be about the soldering, so how easily I can solder the components to these tabs. And obviously I will solder manually, so this will be an extra challenge for this board, but so far it's 10 out of 10. So let me prepare the components. I have all the components and everything for the soldering work, and let's continue the work with this board. So I prepared everything here. As you can see, I have some flux, some very thin, and then I have the microcontroller here. So just to show you quickly why I have these markings on the board, like USB 3, V3 and VB, is because this guy obviously has a USB port, 3.3 volt pin and VB. And then my intention is that this should be under it, obviously with some gap. So then it will be perfectly aligned. So the VB is on this side, as you can see, 3.3 is in this side, and then the USB is here. But when I assemble it, you will see it clearly. So I have a bunch of capacitors and resistors here, and then this one is an OPAMP, and in this I have the voltage reference which is needed for this, and of course some pin headers and some machined pin sockets for the CCD. So there is nothing else to do, is just I try to start and solder the specimens on top of these tabs. So obviously I want to start with the specimens or tiny components first, because it's easier to mount them first, and then I can go in with the pins or the headers, and then finally I can assemble everything and just push together everything. So I need to solder 3 caps on top of this PCB, or on the back of it. So I will start with the caps. So I soldered the passive components and it turned out to be pretty ugly, but at least as I can see, the connections are there. So now comes the difficult part, is to solder the active components, the reference voltage and the OPAMP. So let's do those things. And first I start with the reference voltage because it only has 3 pins. So the voltage reference IC is there. I will try to not destroy it by soldering it. So it seems I managed to solder everything. It's very ugly and not too good, but it's a hand solder, so what could you expect? So now comes the easy part, is to solder the pins. So I will do that now. So there will be a rail here made of 2 female headers. And I will try to use some other jumper pins just to keep the perfect distance between these components. So the spacer is done. Now it's extremely easy to solder everything. But before doing any mistakes, I discovered that I should solder this first, because if I put the rails on this side, it will cover all the pins for the socket for the CCD. So I should do this first. So I have a bunch of CCDs here, and you can see how many pins it has. Here's a nice TCD1304. So first job is done, and I would also like to do this now. So I will do this. So the basic idea here is to assemble this in the following way. It should be, yeah, something like this. Obviously you could do this. I mean, nothing hinders you to solder it like that, and then you can even use like smaller pins, but I want to use these nice sockets, so the microcontroller will be a bit further away from the CCD circuit. So it will be something like this, but I hope you get my point. So then therefore I solder this together. So soldering is done, and hopefully I haven't messed up the soldering anywhere. I did a lousy job with the hand soldering, but next project will be a reflow station, that's for sure. So yeah, this is the top part. Here comes the CCD, this guy right here, and then this is the bottom part where we plug in this microcontroller, and then here we have the USB, so it should face this way, and then just a simple click and it is in the board. But of course first I will program this and then reattach to this board. But as you can see, it looks quite neat, I would say. So then the USB will come here and it will look perfectly, and then I just have to attach basically the CCD to this part, and that's all. So let's attach the CCD. So the CCD has a notch yeah, on one of the ends, and then that notch is aligned with the USB port. So then let's gently push this thing in the socket. And it's in. I think it looks neat. So then the final assembly should look something like this. Yes, I think it's quite nice. And then also one of my ideas is that since we have the USB port here and we have the 4 holes, I can print a 3D printed enclosure around this thing. So then I can use this as just a box, I don't know, a linear CCD box. But of course my idea is to have an enclosure with a hole on its wall, let's say some kind of box, and then I mount this CCD on the box. So then it will have a slit where the light can yeah, meet the sensor, the surface of the sensor, and then basically that's all. So this is the wall assembly. And once again, this nice PCB was made by PCBWay, so they produce this very excellent PCB. Don't forget to visit their website, because you will find some very interesting services, not only PCB making, but also 3D printing, or maybe sheet metal forming, or also CNC machining. And it's not only that they make the PCB, but they can also assemble it for you. So for example, if you don't want to struggle with the assembly like I did for the surface mounted parts, the assembly parts, then I strongly recommend you to use PCBWay's services and just pay a little extra and make these components by them or through them, so it's much more easier. So now I will wire up everything with my computer, and I will show you some pictures from my computer, short clips, if this thing works at all and what's the output of the CCD. So let's go to my computer and test this whole thing. So here we are with the software, which is used to catch the data coming from the microcontroller and plot it. And I put a roughly 1 centimeter wide electrical tape on the middle of the CCD, and therefore we should see some dip in the plotted chart. So we see if we should see that or not. And yeah, I just connect to the microcontroller and I just press start. These functions are not really live at this moment, so everything is just there, so I know that I have to implement them. So let's see what we see. And now we can see that the signal is jumping, but basically this is what we get on the input. And if I stop it in the right moment, I will be able to show you that there is a dip, which is caused by the electrical tape, which basically blocks the light. So I stopped the visualization of the incoming data, and you can see that basically this here is the first pixel, and then we go towards the center of the CCD, And then in the middle, where I have the roughly 1 centimeter wide black electrical tape, we have basically 0 signal. And then it goes back, of course, within just a few pixels to the maximum sort of value, which is again the exposed part of the CCD. And if you remember my previous demonstration, then this kind of signal was inverted, and then this is the correct signal now. So since I used the operational amplifier in this new circuit, I can invert the original output signal of this CCD, which means that instead of the dark areas becoming higher, now the bright areas, the exposed areas on the CCD are the, let's say, bright values. And of course, this can be still further improved in a way that now I haven't picked the values for the resistors very carefully. I just wanted to make it work first, so I just wanted to test the CCD with my new PCB. So therefore I can make this even better, that let's say with a certain light I can be close to the maximum value of the possible values, so something around 4000, and then we can see how the rest is looking like. But at this moment for me this is sufficient, because I can test the PCB and I can test the CCD as well, and both of them seem to work. So it seems that my lousy hand soldering was good enough, so we can extract the signal from the CCD. So I haven't really messed up anything. So that was all for this video. This was my plan, that I wanted to show you my new PCB that I designed, and then PCBWay made the PCB for me, and then I could build everything together with my nearly zero experience in soldering SMD components by using a normal soldering iron. And as you can see, on the software, the data is coming out from the PCB, so we can actually use this PCB and the, let's say, breakout board properly for this CCD. So don't forget to go to my website, link is in the description, and check the link there, because if you want to have this PCB for yourself, then you can buy it through PCBWay's website, and it's a win-win situation for everyone, because then you don't have to struggle with PCB design and so on, and I also get a little support by each PCB sold. So I think that's a good way to have a win-win situation. And also, of course, don't forget to visit PCBWay's website, because they are full of very good services, and so far I'm very satisfied with their PCB services and the assembly services as well, so I can only recommend them. So you should really give them a try if you haven't been already using their services. So I hope you liked this video, I hope you learned something, and see you in the next video.